part 2 of bringing crystal structures to life in Blender, we'll rig our model from part 1 with 2 layers of animation. Layer 1 will use a noise texture to add thermal motion, and layer 2 will use a combination of lattice modifiers and bendy bones to drive large conformational changes. Lastly, we'll parent everything together into a functional rig that's ready for animation. The starting point for part 2 will be the same sphere model that we made in part 1 using geometry nodes, and we're going to add in the layered animation rig using the same geometry node. So we're just going to add to this network. And the reason that I'm continuing to do this by building the geometry node network instead of, say, by adding an armature modifier is that specifically with this layered animation style, I found that if I used modifiers, the wiggle, the thermal motion, would become dependent on how much the model is moving. So if you had a rigged model where something was moving quickly, the atoms that were moving quickly would vibrate faster. And it became very distracting, and it was an artifact that I just could not shake. So instead, we can do this. Actually, it ended up being pretty simple by funneling the geometry in our point cloud through a single node that we can control the inputs on. And that node is a set position node. And you can see it's a simple node compared to everything else we've been using. And you start by inputting your geometry. So this will be the blank point cloud. And then you have the opportunity to change the position of the vertices, or the position of the vertices in that geometry, and also give it an offset. And this is where the layered rig comes into effect. So we're going to add an armature to this position here to let us do large conformational changes, and then we're going to plug a noise texture into the offset to augment that motion further and give it that atomic vibration or that procedural wiggle. So to do the offset, it's a 2-node setup. We're going to need a map range. And the map range is going to be driving a simple noise texture. We are going to switch this over to 4D, and then we're going to have the map range drive the noise texture by plugging the result here into W. Then we want the map range to change the noise texture as a function of time. And if you really want to, you can keyframe. But what we're going to do instead is add a driver. And what we're going to add is #frame. And what this does is ties this value here to whatever the frame is. So if I start playback, you see this begins changing, and it's also changing the input here. The minimum and maximum end up being the frames over which the noise is moving. So minimum is fine at 0, maximum we're going to change to 500. And then I'm just going to add a few settings that I've found helpful. That'll be 6, scale 3, 1.5, 0.1, and 3. And then we can take the color and plug that into the offset. And that's our noise texture. Now, if we want to implement this across the board, we have to replace the old geometry in our different atom groups here with what has been funneled through the set position node. So we can take this geometry, I'm going to apply it to points, and you saw our sulfurs wiggle a little bit because now they have an offset applied to their position. And the way that these nodes are set up, I know that the top one is the incoming geometry, so I'm just going to replace the incoming geometry for the rest of these groups. And if we go back into layout and start playback, now everything really starts to jostle around. And what we have is the world's most biologically accurate ball pit. And it's every molecule, so no matter how deep you go in, everything is moving, jostling just a little bit. To animate conformational changes, we're going to add to this rig using the armature copy that we made of the point cloud in part 1. And you can see if I turn on visibility for that, that's what these little dots are, these little vertices. They are overlaid on top of our other geometry node network. But they are not in the same position because they don't have the noise texture applied to them. So that's why we can see them. And the idea will be that we can animate this point cloud and have all of the positional changes of these atoms reflected in this display geometry node version. And to do that, we're going to grab our armature right here, drag it in, and if we want to move or apply the attribute of the position to our point cloud, so get that into set position, we need a transfer attribute node, and we need to define the basis that we're transferring this attribute. So it's going to be a vector, and we're going to go by index. So that's the basic setup. We can plug this attribute here into position. And now we need to satisfy some inputs. So the geometry is going to be plugged in here as the source. The attribute is going to be position. And the index is going to be index. Now if we go back into layout view, nothing has changed in our model. You notice it still has its vibration, or its thermal motion. But if we grab the armature point cloud and in edit mode begin to move a point around, you'll see that the corresponding point in the display point cloud also moves around, and it still has its wiggle. And this is how we achieve the layered animation, where one armature is moving, it's informing the larger changes in where all the points are, and the wiggle is happening in the background constantly behind that. Let's finish this part of the rig by going into geometry nodes and cleaning things up a bit. And we're just going to take all of the nodes that have to do with animation and Control J to put them in their own frame that we can call animation. And that is our complete geometry node setup. We have our animation and model separate. Now we can turn our attention to rigging this molecule. And rigging a point cloud has a couple unique challenges. For one, whatever finished rig you have, you're not going to want to feel limited in the sort of deformations you can apply. So you want a good squash and stretch with whatever you want to be flexible. But that has to be done with the understanding that if you don't preserve the volume of the point cloud, if you don't preserve the overall geometry, it's not going to look right. And it's going to be too cartoony, which probably isn't the effect you want to have. And the sort of tool within Blender that gives you that mix of control and flexibility is a lattice deform. But before we think about rigging up a more complex shape like this model here, where we have things that might be flexible and other places that might be rigid, let's consider a bit of a simpler model. And for that, I have a geometry node network that's exactly the same, except it is for a molecule of DNA instead of that other monstrosity. And this is more or less a cylinder, certainly by comparison. And it has a procedural wiggle applied to it, and it also has this armature copy. So to start the lattice deformation process, we need a lattice. And by default, this is a cube, but we can start to scale it up, and the goal here is to make a general outline of our molecule. We cannot, as we are doing this, start to change the points from anything other than a rectangular prism. And what I mean by that is, you can see I'm rotating, I'm transforming, I'm scaling, no issues whatsoever. But because of the way that the lattice deform works, the second that we start to go into edit mode and move these points around, that is what's going to drive our deformations. So in general, just make one cage around your molecule, and then we can turn off visibility of our geometry node model, turn on visibility of the armature, select it, add a lattice modifier, select this lattice, and it is set up. Now we can go into edit mode, we can grab the points, and then as we start to rotate them around, you'll see the armature moves along with it. And if we turn back on our geometry and turn off the cloud, we see we have this gentle deform. And you see, as we're thinking about squashing and stretching in weird ways, some rotations here looks a little more natural in terms of how the DNA molecule wants to move, but in other senses, it can get a little wonky. So the trick will be limiting the effect of the lattice so that the distortion is localized, and that's pretty easy to do. We can go into our lattice options and start to increase basically the resolution or the segments of the lattice. So we'll crank this up to 5, and then as we grab some of these middle points now and rotate those, you see that the deformation is a little more localized. All right, that's pretty cool. But how do we animate that? How do we keyframe? The best way to keyframe that I've found, and the way that will actually make this approximate a more traditional rig, is to start adding control shapes. So what I'll do is I'm just going to add 2 for this example. I'm going to grab these middle points here. I'm going to snap the cursor to selected. Then I'm going to add in a circle. And I'll rotate you a bit. And then I'm going to go back into the lattice, back into edit mode, and with these same points selected, I'm going to add a hook modifier, and the object is going to be this Bezier circle, and I'm going to click Assign. Now if we come back into object mode and start to rotate this around, the lattice moves with the control shape, and the DNA molecule moves with the lattice. We can do the same thing with these points up here. I'm going to snap this to the cursor, and then just grab these points again, add another hook modifier, and now if we turn off lattice visibility, we have something that pretty closely approximates a traditional rig, where everything is moving. You can keyframe these positions and everything else, and everything is deforming pretty well. And with some tweaks and maybe some judicious animating, this is a perfectly suitable rig for a simple shape like this. But if we're considering a more complex shape, like the model that we've been building, we have to have a really good idea of the sort of lattices or the sort of movement we want. And for the purposes of this project, I'm going to say that this big chunk here is going to be pretty rigid. It's just going to have the wiggle. And then this chunk is going to move and float a little bit. And then this, we'll call this a lobe. And this down here, this really, really thin part by comparison, is going to move a lot. And we'll call this the furl. And to do this, we can start to set up multiple lattices, because a single lattice won't cut it. We need to have different regions that are animatable. So we can start by adding in our first lattice. And we'll scale it up. And I'm also going to begin placing this based on different viewports or different positions. That's pretty good. That's a good ballpark. Then we will duplicate and scale down. See how far off we are. And again, any deformations I do to the overall lattice in object mode are fine. That's accepted. So I can get away with a lot of placement. But I can't move the points. So I'm doing the best I can to block these out. And I'd say that that is pretty good. And you see we have a little straggler here. I'll try to scale this up so that it'll fit. Okay. And then lastly, we want one down here for the furl. And again, I can rotate this to make it look right. I'm really going to baby this one. This furl is specifically because I want this to move a lot. And that means that everything has to be just right. All right, that's pretty good. All right, so we have our 3 lattices, and we can name them, we'll call this lattice main. We'll call this lattice lobe, and lastly lattice furl. And now we'll turn off the visibility of our main point cloud, of our geometry model point cloud. Turn on the armature, and we'll grab the point cloud, and we'll just start adding in our lattice modifiers. So we have 1, and we will add another one for the lobe, and lastly, we'll add one for the furl. And now, you notice if we start to move the lattices around, nothing. But if we come in and move the points, now everything deforms. And there's already something wrong with this. You see, I'm only moving one of the lattices, and everything is deforming. And that's the same for all of this. And that is problematic because we want to start to limit those regions of movement. And the easiest way to do that is to take advantage of this really nice feature of the lattice modifier, which is to assign it to a specific vertex group. So we'll select our armature point cloud, we'll go into edit mode, and we'll start off by just making a furl group that more or less agrees with where this lattice is. And I'd say that's pretty good. I can see I'm missing some points, so I'll hit Control keypad plus to start selecting a little bit more. And I think we got a respectable amount of points in there. We can always come back and add them if there's an errant lost point. All right, so then we'll go down into vertex groups. Oh, sorry, that's shape keys. Sorry, here we go. We will add a vertex group. We can name this furl. And assign a weight of 1. And that's basically 100%. And this is an important little feature. We'll come back. We'll be using this a lot in a few minutes. And now we can deselect everything. And now we want one just for this lobe. That's better. too bad. We got a little bit extra in here. I'm not too worried about that. That's not going to be moving all that much. And we can come and just edit those points out later too. So we can add a new vertex group. We'll call this lobe, and we will assign those. Now we can go back into object mode, go into our lattice, and for the lobe, we can assign it to the vertex group lobe. For furl, we can assign it to furl. And now we come in here and start to move these lattice points around. We should see that we're limited to wherever the vertex group is. And it's a small victory because it's still not deforming great. But it is deforming only within the area that we want. We can improve the deformation a little bit by increasing the resolution of the lattice. We'll just add a few points in here. So now, when we grab this end, or these end vertices, you can see we're still very limited and still very gentle. But animating these is going to be a pain. You know, even if we really dial in our lattices, adding control curves for each of these is going to be ridiculous, and it's going to be impossible to animate. There's a better way to do it, and I came upon this brilliant tutorial by Level Pixel Level that uses a combination of lattice deformations and bendy bones to get something that is, I think, perfect for this application. So I'm just going to show how the tutorial that Level Pixel Level made would fit into a rig of a molecule. Let's start by adding our armature. So we can go to Add Armature, and we'll get a single bone. And then just like with the lattices, we can start by just generally positioning our bones. So we'll have one that we'll call main. And in edit mode, we'll start to align it in this plane. And we just want to get one basic bone, and then we're going to want one continuous bendy bone to run through here, and then one continuous bendy bone to run through here. So we can extrude, and that will be the base of the lobe. We can extrude here, that'll be the base of the furl, and then we can just extrude all the way down the furl, and here likewise all the way through the lobe. And before we get too nuts about everything else, let's just make sure that these are positioned reasonably within the geometry. That's pretty good. That's pretty decent. And now we'll name this lobe base. We'll name this lobe flex. We'll name this furl base. And we'll name this furl flex. And we can go into our pose mode, and in viewport display, we can turn on bendy bones. And with each of these flex, we can increase the number of segments. Let's say we're at 5. And the same here. And now we can start to add in some control shapes. So the first thing we're going to want is in edit mode. We're going to extrude out of here. And we're going to select this bone we made and the bendy bone. And we can go to Armature, Transform, Align Bones. and that will sort of snap this this end bone here on as an extension of the bendy bone. Or you can do, I believe it is Control Alt A, and we're going to name this lobe point. And you saw as this was moving around, this is where the bendy bone is going to flex to. Is what it's more or less pointing at. But we need another control bone on the end of that. So we're going to go back into edit mode, and we're going to duplicate this bone. And then we're going to change our scaling to scale along the normal and to scale along individual origins so that we can scale out and then use this function here, bone size, or Control Alt S as I just used, to just make a bone that sort of stands out. And now this is our control point. So this is the actual bone that we're going to be animating. And now we can set up some bone constraints to have everything point to this control bone. So we'll grab the control bone, grab the point bone, Control Shift C to bring up our Add Constraint menu, copy transforms. We'll grab the control bone, and now we'll grab the bendy bone, Control Shift C, and stretch 2. Now, the green, you can see we have the constraints applied, but if we begin to move this around, we don't get happy armature, we get angry octopus. And to get rid of angry octopus, we have to undo a mistake we just made by setting this up. And that's we have a duplication of parenting here, where we're asking the bendy bone to move something that's higher up in his parenting. And anyway, the easiest way to do it is just to clear the parent of this control bone. Level Pixel Level does a better job of explaining that than I do and understanding. So we can Alt P to clear parent. And now we move this around, we have our bendy setup. And we can do the same down here. Go back into edit mode. We'll extrude along here. Align. We can duplicate and scale. And we can scale down. Now, while we're here, we can rename flex point, furl point, and furl control. And we can set up our constraints. Now we'll be adding a copy transforms for the point, and a stretch 2 for the actual flex bone. And then to get rid of angry octopus, we'll go into edit mode and clear the parent. And now we have our setup where in pose mode we can move these around. And now we need to link up these movements to the lattices. To link up the lattices to the bendy bones, we can go back into object mode, grab the lattice, grab the rig, and parent as an armature deform. We'll do the same here. And you'll notice that immediately, if we go back into pose mode and begin to move things around, the lattices don't move. And that is because by default, the points within the lattice aren't assigned to anything. So this is where you can think of these as a weight map, and this is where we have to set up our weight maps. Unfortunately, we have to do it manually and make a gradient from one to the other. But it's not too bad because there aren't that many points to deal with. So the first thing that we're going to do is with our lattice selected, we'll go to our lattice options and we'll add 2 vertex groups. And the vertex groups should be named whatever the bones are that are going to deform them. So in this case, everything that's going to be down here towards the end of the furl is going to be furl flex. And everything that's up here towards the base is going to be furl base. Now we can select our lattice. And I mentioned before that we would see this interface again. And now we actually manually have to assign all of our points. And I want to do a gentle gradient between them. But first, we need to understand that the weight has to equal 1 for each vertex. So as we make our gradient from one direction to the other, we have to keep that in mind. So instead of just assigning 1 to, for example, to everything, and getting our heat map here, I'm just going to assign it as 0.75. And then these will be, actually, I'm going to do these as 100. Because we have 4 stages. So this will be 100% or 1. The next level is going to be 75, 0.75. You see I'm assigning these to the flex. So what's going to move down here at the end of the flex has a really strong weight, and then it gets weaker and weaker as it goes up. And we'll make this 0.5. And then we'll have no flex down here. And we'll see if that works out in the long run. Then we'll grab our base and we'll do the same thing in reverse. So we have all 6 points there. We'll assign 1. All right, now if we go back into pose mode and move this around, now we see that everything moves with it. And we can rotate as well. And immediately we have enough to do, some flexing. And then if we were to optimize the lattice points and the weight maps, we could have something that is pretty robust. So again, I'll do this really quickly with the lobe lattice network, and that will be the complete rig. So we'll add lobe flex, lobe base, and for the flex, we'll add U as 1. 5. 0.5. We'll switch over to the base. It'll be 1. 0.75. And 0.5. Go back into pose mode, and now we have a very rough setup that can be tweaked for a pretty decent squash and stretch. All right, the last thing that we can do if we want this to really resemble a traditional rig is start to group everything together and sort of play with the visibility. The easiest way to do that with your armature is while you're in pose mode, select all your bones, and then deselect these 2 control points. And then press M to change the bone layer and banish those bones to something that's not visible. And if you want to get them back, as I want to for this control that I made disappear, you can select within your armature tab here, your object data properties for your armature. Select that bone again, and then here's your second chance to put it in the right layer. All right, so now we have our control bones out. Let's also add in a circle, and this will be our base control. And now we can just start to parent everything together. I'm going to add the lattices. And I'm going to turn these off. I'm going to add the armature proper. I'm going to parent that. I'm going to add the point cloud, the armature point cloud, and parent that. Turn that off, turn on the regular structure, and parent that. And now, if we did everything right, we have our main structural controller. I'm actually going to call it the structure root. And now we have one control that will allow everything else to move around. And then we can step into pose mode and further move everything around. And then as we animate these bones and add the wiggle, everything comes together. So what I'm going to do is spend a little bit of time tinkering with this rig to get it looking just right. And I'll come back and show you what the final deforms look like. Here is my final rig. I spent a lot of time optimizing the lattices, not only in the number of points, but in how the gradient is applied from one influence bone to the other. But I also spent some time optimizing the vertex groups in this point cloud, and the armature point cloud in particular. Much like how we made a gradient across the lattice, you can also make a gradient in your vertex groups just within regular mesh and with normal vertices. And I did that primarily because as the lattice was deforming, there was way too much influence here by the terminus, and it looks like someone took scissors and cut across. So if you see that problem, I recommend changing the vertex group weight in this area down to 0.1 or something. But the end product deforms really well. I'm very happy with it. It's pretty versatile, but also very gentle with its flexibility, and I think I'm going to get a lot of use out of it. But I also did two other major things. One is when I started to do a test animation, I found that having this big chunk of the molecule not move looked really strange. So I did add in another lattice and another bendy bone, just so that I had a little more control over the molecule and it just looked a little more natural. The final big thing that I did to the model was integrate in the cartoon structure. And this is geometry that we exported from PyMol in part 1 and aligned into the point cloud. And it's here with the end goal being that I have the sphere representation of the molecule acting as an electron density map or a shell around the cartoon that's inside. But for that illusion to hold up, the cartoon geometry needs to deform along with the electron density map. And to achieve that, I added the same lattice network, the same lattice modifiers that I did on the structure Armature. And I also added some vertex groups for cartoon furl and cartoon lobe, and also optimized that so there's a bit of a gradient. And the end result is that the cartoon geometry deforms really well by itself, and even when you layer on the structure geometry later, they both deform very well. So this is looking very good for the type of animation I'm looking to achieve. So in summary, we finished rigging this molecule, this point cloud, with 3 types of motion. We have the procedural wiggle, the thermal motion. We have the ability to affect large conformational changes while maintaining that wiggle. And then the top layer on top of all that is the ability to move the whole rig around if we want to simulate Brownian motion, or just give it a spin or whatever we would like. Thank you for watching. Stay tuned for part 3, Metaballs and Shading.